Okay, so in 12.1, and I went over general sequences. Now we're going to be more specific. We're going to talk about arithmetic sequences. And by the way, there's a handout for arithmetic and geometric sequences on D2L under content, and it's actually in the notes too. It's right here. Talks about what is an arithmetic sequence, what's the nth theorem of an arithmetic sequence, and then the sum of the first n terms of arithmetic sequences, and the same for geometric sequences, which we're doing 12.3. So please go over this handout. It's very informative, it's very detailed, it has a lot of examples. Right? So a sequence is arithmetic if the difference between any two consecutive terms is constant. For example, 2, 4, 6, 8, 10, and so on. 4 minus 2 is 2, consecutive terms. 6 minus 4 is 2. 8 minus 6 is 2. 10 minus 8 is 2. That's the constant that we're talking about. That constant is called the common difference. That constant is called the common difference. So an arithmetic sequence would look like this. Like this is 2 plus 2, 2 plus 2 times 2, 2 plus 3 times 2, right? 2, 4, 6, 8, and so on. So it's going to be A1 is the first term, and then you keep adding the common difference. A plus D, then A1 plus 2 common differences, then A1 plus common differences, 1, A2, A3, A4. So the nth term, you can see the 1, you have 0 common differences. A2, you have 1, A3, you have 2, A4, you have 3, and you're going to have n plus 1 common differences. So this is called the nth term of A, which is the general term. You know, in the previous section, to find the nth term, we had to find a pattern. Once we know it's arithmetic, the pattern is right there. The term of a arithmetic sequence is an equals a1 plus n minus 1. Okay. So here's another example of arithmetic sequence. 1, 3 over 2, 2, 5 over 2, 3, and so on. How do we check if it's arithmetic? Again, we do A2 minus A1, always the next minus the previous one. A2 minus A1 is 1/2. A3 minus A2, 2 minus 3/2 is 1/2. A4 minus A3 is 1/2. A5 minus A4 until there's no more. 3 minus 5. So that's it. Arithmetic with a common difference of 1/2. Okay, let's look at number 16, page 857. 16, page 857. It says, find the nth term of an arithmetic sequence with given first term and common difference. What's the 10th term? Okay, so if we're given A1 is root 3 and the common difference is root 3. What's the nth term? We know it's arithmetic, they're telling us. So we should know this formula, n minus 1d. A1 is root 3, d is also root 3. So let's distribute to make it look simpler. This equals root 3 plus n root 3 minus root 3. So now you can find any term you want. They want the 10th term, so n is 10. It's 10 root 3. Okay. 24. Page 857, number 24. It says the first 4 terms of a sequence are given. Can these terms be the terms of arithmetic? If so, find the so we have to check if it's arithmetic. Let's see. ln of 2, ln of 4, ln of 8, ln of 16. We're gonna check the difference of every consecutive term. So a2 minus a1, ln of 4 minus ln of 2. Using the control of logs, this is ln of 4 over 2, which is ln of 2. a3 minus a2, ln of 8 minus ln of 4, which is ln of 8 over 4. So far so good. Now a4 minus a3, ln of 16 minus ln of 8, ln of 16 over 8. So they're all giving me the same common difference, so it is arithmetic with a common difference of ln of 2. If so, find the common difference, which we did. Number 30, page 857. We're given an equals 1 plus n over 2. It says find the first 5 terms of the sequence and determine whether it's arithmetic. If it's arithmetic, find the common difference and express the nth term in standard form. Okay. So let's find the first 5 terms. a1 is 1 plus 1 half, which is 3 over 2. a2 is 1 plus 2 over 2, which is 1 plus 1, which is 2. a3 is 1 plus 3 over 2, 5 over 2. a4 is 1 plus 4 over 2, 1 plus 2 is 3, and a5 is 1 plus 5 over 2, 7 over 2. You can tell that the common difference is 1 half, and they want us to write the nth term in this form. Let's do that. an is a1 is 3 over 2 plus n minus 1 times 1 half. Of course, if you distribute the 1 half, you're gonna get this. You're gonna get 3 halves minus 1 half, which is 1, and then plus n times 1 half, which is n over 2. But this is the standard form that they want. Okay, 42. It says determine the common difference, the first term, the nth term, and the 100th term of the arithmetic sequence. So we know it's arithmetic. 15, 12.3, 9.6, 6.9. So there's 4 terms. Let's answer the questions one by one. Determine the common difference. So all we have to do is find a2 minus a1. Now, because we know it's arithmetic, we don't have to check. So the common difference is negative 2.7. The fifth term. So to get the fifth term from the fourth term, you add a common difference. a5 is a4 plus d. So 6.9 plus negative 2.7, which is 0.2. So the next one is 0.2. What else do they want? The nth term and the 100th term. The nth term is the general formula, standard form. an is a1 plus n minus 1b. It's 15 plus n minus 1 times negative 2.7, and that's that. So we can make it simpler. We don't have to keep it in standard form. So 15 minus 2.7n plus 2.7, that's 17.7 minus 0.7. And then they want the 100th term. So 17.7 minus 2.7 times 100, which is 270, so it's negative 252.3. Okay, if I give you a question on the test, if I say given the 12th term of an arithmetic sequence to be 32 and the 5th term to be 18, find the 20th term. You know, we know it's arithmetic, okay? So, okay, if you notice, to get the nth term from the first term, we add n minus 1 common differences, okay? Same idea here. So we need d. We can't move on without d. So if we have the 5th term, to get the 12th term, we have to add 12 minus 5, which is 7, and check it out, 7 common differences. Okay, always true. So if we have this and we want to get the 12, we add 12 minus 5, which is 7. So to find d, we plug those values in. Plus 7d, 32 minus 18 is 14. The common difference is 2. Now we can find any one we want. A20, we can start with A5, A12, it doesn't matter. If we start with A12, we add 20 minus 12, which is 8. Because we don't have A1, so we have to do this. 32 plus 8 times 2, 48. Let's look at 48 on page 857. We gotta practice these. I always have something like this on the test. It says the 12th term is 118. And the 8th term is 146. So given, and it's arithmetic, okay? Find the first and the nth term. Find A1 and A. Well, again, we need D before we move. So A12 is A8 plus 12 minus 8 is D. 118 is 146 plus 4D. 118 minus 146 is negative 28. So the common difference, negative 28 over 4 is negative 7. So now we can find the first term and then the nth term. To find the first term, we can use A8 or A12. It doesn't matter. A1. 8 minus 1 is 7D. So 146 is A1. 7 times negative 7 is negative 49. If we add 49 to 146, we get 195. So A1 is 195. And then the nth term, AN is A1 plus N minus 1D. 195 plus N is 1 times negative 7. Okay. Now, the example on page 10 star in the notes. Don't look at the answer, just try to do this, okay? It's in the notes. The 6th term is 17 and the 4th term, just like what we did. Okay, number 50, page 857. 50, page 857. It says the first term is 25 and the common difference is 18. Which term of the sequence is which term of the sequence is 601. So we know that AN is 601. We want to find N. Which is it the 10th term? Is it the 100th term? One way to do it is to keep adding 18 until to get the 601 and then count the terms, which is going to take you forever. Or we can do this. Oh, wait. I'm sorry, this is 49. I don't want to do 49. I want to do 50. 49 is your homework. This is 49. That's your homework. So let's do that. Number 50. The first term is 3500. And the common difference is negative 15. Which term is 2795? So good luck going through this. Okay. So to do that, we have an and we have a1 and we have d, so we can find n basically. An is a1 plus n minus 1d. 2795 is 3500 plus n minus 1 times negative 15. So 2795 equals 3500 minus 15n plus 15. So this is 15 minus 15n equals 2795. Subtract 3515. Subtract 3515. And you get negative 720 equals negative 15n, and is 48. So which term? It's the 48th term. And you can check that manually, but it's going to take you a while. Okay, now, so if we have individual terms, we get a sequence, arithmetic sequence. Now, if we add them up, if we add up those terms, the sum of the first n terms would be 10, could be 15, could be 1000. It's called nth partial sum of an arithmetic sequence is Sn is n, the number of terms you're adding, the sum of the first and the last divided by 2. But it's not hard to prove this. Remember, Sn is a1 plus a2 plus a3 plus an. Let's write it in two different ways. Let's write it as a1 and a2. Remember, a1 plus 1 common difference. a3 is a1 plus 2 common difference, and an is just an. Okay, and then write it backwards. An, and then the one before an is an minus, if you go backward, you minus a common difference. An minus 2 common differences, and then a1. You add them up, Sn plus Sn is 2Sn. This is a1 plus an. You add these cancel out. So you can see a1 plus a, and then the last one, a1 plus an, and it's n of them, right? So 2Sn is n, a1 an, divide by 2, and you get that. So if you okay. This is for adding the terms, this is for finding a specific term. Okay, be careful of an arithmetic sequence. This is for finding a general term or a specific term. This is for summing, adding the first term, n terms, 10 or 100. Adding just individual terms. So here, when it says find the sum, example, find the sum of the first 1000 counting numbers. So basically, how do we add? Of course, we can do it on the calculator. It will take us a while. So we have, remember, this is an arithmetic sequence. 1, 2, 3, 4, up to 1000. It's an arithmetic sequence. There's n of them is 1000, and the common difference is 1. Right? So if we're adding them, it's n over 2 a1 plus an. There's 1,000 of them. The first term is 1, the last one is 1,000 divided by 2, and that's got 500,500 if you add up all these. 62, page 857. A partial sum of an arithmetic sequence is defined the sum. So negative 10 minus 9.9 minus 9.8 minus 0.1. So basically this is negative 10 plus negative 9.9 plus negative 9.8 plus negative 0.1. This is an arithmetic sequence. The common difference obviously is if you A1, A2 is negative 9.9 minus negative 10, which would be 0.1. The first term is that, the last term is that, but how many terms do we have? We don't know. We gotta find how many terms, because this equals n over 2 a1 an. We have a1, we have an, we need n. How many terms are there? We knew because there was 1,000 of them. So we're gonna use that formula, two formulas, this, so that's it. N minus 1b, an is negative 0.1, a1 is negative 10, n is what's unknown, and d is 0.1. So if we do the math, negative 0.1, negative 10, plus 0.1 n minus 0.1. So it's going to be n equals 100, and then you put that here, negative 10 plus negative 0.1 divided by 2, and it's going to be negative 505. One more, and then we're done. 74, page 858. A drive-in theater has spaces for 20 cars in the first row. So 20 cars in the first row, 22 in the second row, 24 in the third row. So A1, A2, A3, and if there are 21 rows in the theater, find the number of cars that can be parked. So there are 21 rows, so we want to add up all these. And so if you look at an is a1 plus n minus 1d. So there are 21 rows equals a1, which is 20, plus 20d. So the 21st row is going to be 20 times 2, d is 2, 4 is 2, so you're going to go up to 60, and that's the 21st row. Okay, so now we want to add them up. 20 plus 22 plus 24 plus 60, that's the sum, remember, that's the sum, so it's n over 2 a1 plus an, and 21, the first row has 20, the last one has 60, so you can park 840 cars in that theater. Alright, 12.2 is done. Until 12.3, have a good day.